So since we're going to be spending so much time working with sine and cosine, we want to consider the general form for these two functions. So the general form for sine and cosine are y equals a sine of bt plus c and y equals a cosine of bt plus c. As you can imagine, if we're talking about sine and cosine without anything done to them, that means that a would be 1, b would be 1, and c would be 0. But we know that we can put some actions onto these functions to change what happens to them. So a is going to take our graph and either stretch it or shrink it. Because sine and cosine live between 1 and -1, that also means that if we multiply by a, that's going to change our amplitude to be a. So our amplitude is the absolute value of the number that multiplies in front of sine or cosine. Remember, amplitude tells you how much you vary from the midline. So amplitude is always reported as a positive number. We have to keep that in mind when we're thinking about our functions, that if we know the amplitude, it doesn't necessarily mean that the number in front was positive. The number in front could have been positive or negative, but we took the absolute value. The period of the function is normally 2 pi. So that means that if there's a different number inside of our function, we need a way to account for that. So our period is 2 pi divided by b. So here we can find out our b. So here we can find out our period by taking whatever number was put inside the function and dividing it into 2 pi. Our vertical shift is c. So remember, if you add or subtract something from the end of a function, if you add it, it moves the function up vertically, and if you subtract it, it moves the function down vertically. So even though we have all these letters as part of our general form, there are things we've been working with already in this course. So let's take a look at some examples. Example 2. Find a possible formula for each of the following functions based on their graphs. So here, what we're going to do is we're going to look at this graph and try to make a good judgment call about whether it's sine or cosine, and then from there find things like the amplitude, the period, and the shift. So if I look at this graph and I look at the shape of this graph, I really want to consider what's happening starting at 0 and ending at roughly 2 pi, because that's where my graph starts to repeat. So I can see that the period hasn't been altered here because it goes from 0 to a little bit past 6, which is what sine or cosine does. Now, looking at the shape of this graph, it doesn't have the hallmark U shape that cosine does. So this looks an awful lot like sine. However, if I think back to what my sine graph looks like, sine starts off increasing and then decreasing. So what I notice here is that the sine graph has been rotated about the x-axis. And I know that in order to have a rotation, I would have need to multiply by -1. So I'm expecting something like negative sine x. So the other piece I need to consider is whether or not my amplitude has been changed. So again, I'm going to go ahead and find the maximum y value, which here is 3. And then I'm going to find the minimum y value, which is -3. And I'm going to divide that by 2. 3 minus -3 is 6. 6 divided by 2 is 3. So my amplitude here is 3, which means I would have need to multiply my sine function by 3 in order for it to be able to live between 3 and -3. Now, again, amplitude is reported as positive, so the amplitude is 3. But the function itself doesn't need to have a positive a. Instead, I need to look at the graph and determine if it was a regular sine graph or it had been rotated. Since it was rotated, the negative needs to go with my sine. So I'm saying that this is the function -3 sine x. You can check this by graphing that on your calculator to make sure it matches what you're seeing here. For the next graph, I'm again looking at what happens at x equals 0 and where and when it starts to repeat. So again, it looks like it goes until a little bit past 6, which for me means that the period hasn't changed. So I look at the shape of the graph between 0 and 2 pi, which is a little bit past 6, and it's got that U shape, that sort of drop, which is a shape that cosine takes on. So this is looking a lot like a cosine graph. So I'm going to use cosine as my starting point. So now I'm going to consider the amplitude. So again, I'm going to take the maximum value, which is 3, minus the minimum value, which is 1, and divide by 2. 3 minus 1 is 2, divided by 2 is 1. So my amplitude is 1. And here, it doesn't look like my cosine graph was rotated. So I'm pretty sure that my amplitude here is positive 1. I can write that in, or I could just leave it as cosine. Now, because my period didn't change, that means I don't have anything multiplying inside. And the last thing I need to consider is whether or not this graph was shifted. Now, the reason I'm asking if this graph was shifted is because it's not symmetric about the x-axis. In the last problem, my maximum value is 3 and my minimum was negative 3, which means it was symmetric about the axis because the maximum and minimum were the same number, but one was negative and one was positive. That's not the case here. The case here is that my function is living between 3 and 1. And so that tells me that my graph has been shifted up. So what I can do to figure out what my shift is, I can either reason through where my maximum needs to be, or I can use a shortcut formula. So if I'm going to reason through, I would remember that the maximum of cosine is 1. But now, looking at this graph, the maximum is 3. In order to get from 1 to 3, I would need to add 2, which means that my shift would equal 2, which means that my function would need to add a plus 2 on the end. However, there is a shortcut formula we can use to find the shift. The shortcut formula says takes the maximum value, which is 3, add the minimum value, which is 1, and divide by 2. 3 plus 1 is 4. 4 divided by 2 is 2. So this is slightly different than the amplitude because the amplitude looks at the difference between the maximum and minimum, and the shift looks at the sum of the maximum and minimum. But in both cases, we divide by 2. So this particular function, I'm going to say, is cosine x plus 2. Again, a good way to check this is to graph it on my calculator. Finally, let's look at this last graph and see if we can figure out what kind of function it is. So again, I'm going to start at 0, and I'm going to see where I start to repeat. So here, I see that I start to repeat a little bit past 3. That gives me a clue that it probably goes until pi, because pi is a little bit past 3. But that's different than the little bit past 6 that we've been seeing before. So that tells me that my period has changed. So that's something I'm going to need to consider. So I need to figure out if this is a sine or a cosine. Now remember, sine functions have 2 bumps in them, whereas cosines generally have 1 bump for each period it takes on. This one only has 1 bump. So I think that this is a cosine graph. Now, to find the amplitude of this graph, I'm again going to look for the maximum value, which is 4, minus the minimum value, which is negative 4, divided by 2. 4 minus negative 4 is 8. 8 divided by 2 is 4. So I know that I'm going to have a 4 in front of the cosine, but I need to figure out if it's positive 4 or negative 4. Since cosine usually starts at a maximum, and in this case it starts at a minimum, I'm feeling fairly confident that it was rotated around the x-axis, and therefore this should be negative 4 cosine. Now, in this one, remember that our formula for the period is 2 pi over b. And b is what we normally plug in to our function. Now, looking at this graph, I'm pretty confident that my period is pi because it ends a little bit past 3. So since 2 pi over b equals pi, I can solve for b. I can multiply this b up and then divide the pi down. And if I do that, algebraically, I get that b equals 2. So here, I'm going to fill in a 2 inside my argument. So I have negative 4 cosine of 2x. Now, I need to determine if it's been shifted. Again, I see that this function is symmetric about the x-axis. So it varies between 4 and negative 4. So the same number in the positive direction as the negative direction. And that tells me that it's not been shifted. However, if I use my shortcut formula, I can add 4 plus negative 4, which is 0, divided by 2. 0 divided by anything is 0. So my shift is 0. There's no shift here. So my function for this last one is negative 4 cosine of 2x. Finally, we have example 3. Here we have a word problem, and we want to figure out a way to take this word problem and figure out the associated function in terms of sine or cosine. So the example says, Boston averages 15 hours of daylight in June, 9.5 in December, and 12 in both March and September. Assuming that the number of hours of daylight varies periodically over a period of 1 year, write an expression for n, the number of hours of daylight, as a function of t time. Let t be in months and t equals 0 correspond to the month of June. So there's a lot of information here. One of the most important pieces is that t equals 0 corresponds to the month of June, which means that when my function begins, the measurement begins in June. So I know that in June, I have 15 hours of daylight. So that means if I want to take a stab at graphing this function, when I start my graph, I'm going to start at 15. So when time equals 0, the daylight is 15 hours. So there's a lot of other information that I want to plot here, and that'll give me a sense of what my graph should look like. So let's see what else I know. In December, I have 9.5 hours of daylight. So December is going to be 6 months after June. So that's going to be t equals 6. So t equals 6 is going to give me 9.5. So I'm going to go to 6. I'm going to go up to roughly 9.5. I think that's going to be about here. I also know that I'm varying periodically throughout the year, which means 12 months later, I'm back in June. I should be back up to 15. But I also know something about March and September. So March and September are going to have 12 hours of daylight. So March is going to correspond to 3 months after December. So that's time equals 9. So I'm going to go up to 12, and I'm going to draw in my dot there. And September is 3 months after June. So t equals 3. I'm going to go up to 12. And I'm going to draw in my dot there. So looking at my dots on my information, I get the sense that this is going to be a cosine graph, because if I connect these dots, this has a distinct cosine shape. If I had a sine graph, my original function would have been increasing to start, but instead it was decreasing to start, which tips me off that it's going to be cosine. So here I have cosine as my outer function here. And remember that my independent variable is time. So I'm going to have a t in here. And I need to figure out my amplitude, my period, and my shift. So let's start with the amplitude. So the amplitude, I'm going to take my maximum value, which appears to be 15, minus my minimum value, which is 9.5. And then I'm going to divide that by 2. So 15 minus 9.5 is 5.5. And if I divide that by 2, I get 2.75. And because this doesn't look like it was rotated, it looks like the general way cosine is shaped, I'm going to report that as positive 2.75. Now, the period is 12 months because after 12 months, the whole cycle starts again. So that means that my 2 pi over b is going to equal 12. So again, if I want to solve for b, I'm going to multiply the b up and I'm going to divide the 12 down. So I'll get b equals 2 pi over 12, or b equals pi over 6. So that means that over here inside my function, I'm altering the period from 2 pi. And so I put in the pi over 6 to get my function to have the correct period. Now I have to figure out if it was shifted. This is certainly not symmetric about the x-axis. Instead, I'm varying between 15 and 9.5. So again, I can figure out my shift either by reasoning through it or using the shortcut. If I use the shortcut, then my shift is going to be the maximum plus the minimum, so 15 plus 9.5 divided by 2. So if I were to divide that out, I would get 12.25. And I know this is shifted up because normally I live between 1 and negative 1 with cosine. And if I multiply by 2.75, it would then live between 2.75 and negative 2.75, and this is much higher. If I add 2.75 to 12.25, I get 15, which is my maximum now, and corresponds to the information I have. So the function that best models this scenario is 2.75 cosine of pi over 6 times t, all plus 12.25. So being able to take information from a word problem and assign it to a periodic function is incredibly powerful because, again, this will help us predict what might happen at a later time. So this is something we're going to be doing out throughout this course.